Hi everyone, thank you for joining us. My name's Dima Amin and I'm a technical analyst here with Geosoft in our Toronto office. And I'd like to welcome everyone to today's webinar and introduce you to Birgit Woods, who will be presenting and showing you some of the features of our target software. Birgit's a technical analyst here at Geosoft, and her area of focus and expertise is geology and our target software. So now that we're all set, I'll hand it over to Birgit and we'll get started.
Thank you, Dima. Hi, everybody. As Dima said, my name is Birgit Woods, and welcome to this webinar on drill hole exploration workflow made easy. As Dima said, I'm a technical analyst at Geosoft, so I provide training in a variety of our software packages, including Oasis Montage, Target, and Target for ArcGIS. And I give demos just like this at trade shows or online as part of webinars. So today what we're focusing on is Target. And to give you an idea of what to expect in this webinar, I'll be starting off with an overview of what Target can do, but the bulk of this demo or this presentation will be in the live demonstration portion. So I'll show you all of our Target surface tools and drill hole tools and our 3D capabilities as well. At the end, I'll also briefly discuss our tool Seeker, which is a method of accessing more data for your maps. Just as a brief introduction to what Target is. Target is used to visualize and analyze large volumes of data. And this can be surface data or drill hole data. So you can use this to visualize geochemistry surface soil samples as well as geophysics surveys, but also to visualize drill hole, borehole subsurface data. We have set up our software to be easy to use with an easy to follow workflow, and that's something that I will be demonstrating for you as well. We are industry partners with ESRI, so I will be demonstrating the ESRI integration capabilities as well. And we'll jump into the live demonstration. So here's a picture of me giving a live demo at our PDAC booth this year. You should all be able to see right now my screen where I have Target activated. So Target exists on its own as a standalone piece of software, or it also functions as an extension within Oasis Montage. We also have an extension called Target for ArcGIS, which works within the ArcGIS platform. So what I'm focusing on today is the Target as you would see it in the standalone product or within Oasis Montage. What you see here is a regional map, and I am focused on an area of Kootenay, British Columbia in Canada. And when with Target, you have access to three main menu items. There's the surface mapping menu, DH data, which stands for drill hole data, and drill hole plot. So the surface mapping menu is what I'm going to focus on for the moment here. With the surface mapping menu, you can import data from a variety of different formats, whether it's geochemistry survey data, geophysics data, and you can specify the coordinate system for this data. Then you can create a map, add base map elements to it, and then do all kinds of symbology and import from other GIS platforms and sources. As I said in the intro, the menus are set up in a top-down fashion to help you with your workflow. So generally you can start at the top and work your way down. All of the other menus that you see within the application allow you to do things in addition to what you would see in these core menus here of surface mapping, DH data, and DH plot. As I mentioned also, we are industry partners with ArcGIS, so that means when you install Oasis Montage or Target Standalone, you have the ArcGIS engine installed along with it. And what that means is that using the ArcGIS menu, you can open an MXD, which is the native file format for a map in ArcGIS. You can also save the current Geosoft map as an MXD, or you can open an MXD as I have here within the within Target Standalone or Oasis Montage. With an MXD open here, what I can do is click on one of the layers here and drag and drop it into my Geosoft map. So the cross functionality is really great across these platforms. And so now what I've done is I've imported this geology layer on top of this regional layer here. Just continuing on with the surface mapping capabilities, I have a snapshot view of some soil geochemistry that I've imported. So I've just jumped into this area on that larger map, and here I have imported some geochemistry soil sample data, and at the moment they are proportionally sized and colored based on their concentrations of copper at each location. So this was done using the Surface Mapping tab under Symbols. And what you're able to do then is create a raster representation of it. So with the point data that is imported, whether it's elevation, geophysics, geochemistry, it doesn't matter what, if it's point data, you can create a raster, or what we call a grid for it. And here's an example of the raster interpreting between the data points here, which can be colored according to your own coloring scheme. Once you've created a raster, you can contour it. So here's an example of some contours that I've created. And with these contours, you can control the interval, which levels are being represented, which ones are being labeled, and how they are colored. So that is the surface mapping menu. DH data and DH plot are the core menu items for handling drill hole data. And so let's get into that. If you look at DH data, this is the menu that's used for importing and managing the drill hole data. So you would start by creating a drill hole project, and then you would import. And we can import from a variety of different formats, whether it's a CSV file, a text file, an Excel spreadsheet, and Microsoft Access database, or some of the other file formats that you see here. We can import from there. So what you would do is first import your color table and a survey table. You could also import geochemistry along the drill hole traces, geology. And on the left here, I've just opened up in my Project Explorer all of the data that I've currently loaded in. I'll just open up the geochemistry table so you can see what that looks like. And look, right now I'm looking at data for one particular hole. What I can do is view statistics for this data based on a selection, or I can select all of the values across all of the holes. Another interesting thing is that you can view the results in a profile window below. And so you can superimpose multiple results in the window below. And I'm going to use my page up, page down button to scroll through the different drill hole traces so you can see the data distribution across all of them. Lithology is set up in a very similar way. You have from to intervals. From this depth to this depth, we have this type of rock. And using this information, you can build what we call a rock code file. So a rock code file allows you to associate a color and pattern to each of your rock codes. And when you click on Populate from Channel, it just imports them from the data that you have imported. You can then type in a description and use the dialog box here to specify what kind of patterns you want associated to it. The rock code file is saved to a CSV file, which is shareable. So only one person at your company would need to do this. The CSV file can be shared and then used in the maps across your data, across your industry, your company. That way the colors and the symbols are standardized throughout all of your maps. Once you've imported your data, you might want to specify the coordinate system before making any maps. So we have a dialog box that allows you to do that easily. You can specify the datum, the local datum transform, and the projection method. We have a copy from option as well, so if you prefer to use ESRI projections or if you have existing data that you'd like to pull the projection from, then you can do that from here as well. So that's really easy to use. QA/QC is another important option as well. What you can do here is specify what things to look for. So these are common errors that occur when logging drill hole data. For example, in from to data, so this would be your geochemistry assay table or maybe your geology table, it will look for errors such as the froms or the tos that are greater than the whole bottom, overlapping intervals, missing intervals, duplicate sample numbers, out of sequence intervals. And for your color table, there's also another set of things that the software will look for. And with your survey table as well. So with this information, what you can do is create a report looking at all of the drill holes and all of the data types to see what kind of errors are resulting from this. And so we have here in this data set a lot of missing intervals, so that just means that there's a lot of blank space, and some 2's are greater than the whole depth, things like that. So at this point, what we would suggest is that you provide this report, which is in Notepad, to whoever is your database manager, and we suggest that they update the data at the source. So whether you've gone out into the field and collected more drill hole data and you want to update your project from that, or if you have made correction based on the QA/QC tool that I just showed you, what we would do is update the source data, and then you can go back into DH data, refresh project. So with essentially one click, it will re-import all of your databases for you, because the import settings that are used within the import wizard are saved. So it's a really easy process to update your databases with new information coming from the field or corrected information at the source. Once you have imported your data and specified a coordinate system, then you can start creating maps. And so I have several maps made already ahead of time, but I'll just show you what is involved in creating a map using our tools. So I've selected the Plan Maps dialog here, and all of our maps are created using these dialog boxes, and it's an iterative process. So you come in here, you make modifications within these tabs, and then look at the result. And then you can come back in here, make modifications to then update your existing map. So I have an example of a plan map here. And on this plan map, what I've done is I've colored all of the colors based on their depths, and that appears in the bottom left here in the legend area. Along the drill hole trace, I have these numeric bands which show the medium and high level grades of molybdenum along the drill hole traces. And in the background, I put in a magnetics grid, so a raster representing magnetics. And using our tools, you can put satellite imagery in the background, any other kind of georeferenced image you like. Along the drill hole traces, we have a lot of choices. You can plot with a bar plot, numeric bands as I have here. You can post text, post values. You can also create grids based on data along the drill hole trace, and I will get into that when we talk about sections. When it comes to making a section, you go into DH plot section, and again it opens a dialog box that allows you to specify the section location and the data that is being plotted along the drill hole traces as well. When it comes to creating a section, you define it interactively using your plan map. And so you would draw a box, reposition that box, and that defines your section location. You can also create multiple sections at once. So right now I'm setting the number of sections to 3. When I click on Define, so here I can create 3 sections at a time using the same parameters that I have defined in here. So once I've created a section, and I use the Data tab to display data along that section, you can see here I have multiple options here for creating a bar plot. I can do section grids using Kriging minimum curvature or TIN-based gridding algorithms. We have numeric bands, you can post values, you can drop profiles along the traces, and if you have structural data, you can plot structural ticks. So what I'm going to do is show you some examples of some section maps that I've created here. Here's an example of one section where along the drill hole trace I have a bar plot of molybdenum. And in the background what I've done here is created a raster, so a section grid based on the values of copper along the drill hole traces. This grid that is created is automatically georeferenced in 3D, so I will be able to import that grid into the 3D viewer, which I'll show you in a minute. And here's another example of a section. And along the left side of the trace I have rock patterns, and along the right side of the trace I have another bar plot for molybdenum. This is an interesting section because it's something that has been created by one of our clients. So you can see here with this example there's quite a few options that you can do for specifying what kind of data to plot along the drill hole trace. It can become quite complex. So this has several rock patterns associated to it, numeric bands. There are significant intersections also being plotted as well. Using our CAD tools, you can draw interpretations into your section. And I'm just going to open up the first section I made. Earlier, I made this section interpretation over this section view, and you'll see that this section interpretation is 3D georeferenced. So I can export it into a DXF or into a GeoTIFF, and it will be 3D georeferenced, and I'll be able to view that in my 3D viewer. So that's it for sections. Let's close that down. We can also create stacked sections, and here's an example of that. So when you're creating a multiple section, you have the choice of creating it on separate maps, as you saw earlier, or you can create stacked sections where you're seeing it one over the other layered on top of each other like this. And on these sections, I have section grids, I have a bar plot of molybdenum, and I also have the rock codes also being displayed as well. So that's stacked sections. Another type of plot we can do is fence diagrams. So a fence diagram is used to look at the rock types across your drill hole traces. So what it does is it creates these polygons that connects the lithologies from one drill hole to the next. And even if your drill holes are curving, the fence diagram represents them vertically so that they can connect in this way. The fence diagram is another way of creating a section view that doesn't follow a straight line, so that's another advantage of using the fence diagram. We can also export the fence diagram to an AutoCAD 3D DXF file, and that way you'll be able to see it in our 3D viewer, which I'll show you in a minute. The other type of maps that we can create are strip logs, and this is essentially a report. So on this one map, you can see the data associated to one drill hole. And so this one drill hole, I've plotted the alteration assemblage, molybdenum, a bar plot, as well as some values associated to it as well. Copper, cobalt, nickel. So this is a very simple strip log. With strip logs, you have the option of placing up to 32 different items in your strip log to represent the data for one hole. In addition, if you do have structural information like a dip in a dip direction associated to structure measurements, you can create fracture density plots, which is what I have here, but you can also create stereo nets and tadpole plots as well within a strip log. And to create a strip log, it's again under the DH plot menu, strip log. You can add data through using this drop-down list of tools within the dialog box itself, and it's fully customizable as well. The spacing between each of those data lines, how you want them to be plotted on the page. So it can really become a customized tool. When it comes to plotting multiples of them, you could do it for a range of holes. You could create these strip logs for a selection of holes or all of the holes, and you can change the scale as well so that it fits on each page, or it represents a specific interval, or have it fixed at a certain scale. So there's a lot of options there for strip logs. All right, so the next type of map that I wanted to show you is a 3D map. The 3D map is really easy to create. Again, as soon as you import your data and specify a coordinate system, you can create a 3D map. And I have a 3D map here open. So what you're seeing right now is the static view of a 3D image. And this is basically the printout version. This is ready to go, ready to print. If I want to open up the 3D viewer, I'm just going to open up using this cube. And this is the 3D viewer where I can add all kinds of information to my maps. If I go into Add to 3D, drill holes, this is how the drill holes are being plotted, as well as the data along those drill hole traces. So you can plot rock patterns, bar plots. We have something called structural ticks as well, so this will put structural disks along the drill hole traces. The topography tab will allow you to bring in topography, and it will clip that topography to the extent of your selected holes. You can modify how the hole traces are being plotted as well. So what I have here currently visible along the drill hole traces, I have a bar plot showing my molybdenum values. And what I also have is rock codes, so I can display both of them at the same time in this 3D map. On the top I have topography, and it has been clipped to the selection of holes that I have here. And it has been overlaid by a raster. So it could be any type of raster. If I had satellite imagery, I'd be able to paste that on top of the topography as well. So in addition to displaying data along the drill hole traces, what you can actually also do is create rasters at horizontal and vertical intervals using the data from those drill hole traces. So in this case, it's using the values of molybdenum along the drill hole trace at very specific horizontal intervals, reference levels, or elevations. So we can create those two-dimensional grids, but we can also create a three-dimensional grid, which is what we call a voxel. So here's an example of a voxel, where each cube represents a single data value. And in this case, this is molybdenum. To create this voxel, it's really easy. You use the Utilities tool and then go to 3D gridding, and you use the drop-down list to select which attribute from which column you want to use in your to create your voxel. There's a cell size that can be computed for you, and there's lots of advanced options if you want to control the interpretation distance, your log options, or if you are familiar with variograms and kriging, you can modify the options that go along with that. So here we go. We have some range, sill, and nugget values and model that you can modify for the variogram. But very basically, the voxel that is generated using our default settings is usually quite good. And here's an example of the voxel for molybdenum. If I click on it in this table of contents here, you can see that I have tabs below that allow me to visualize it in a different way. So I can use the transparency controls to modify the transparency of it. I can use the color tool to modify the coloration as well. And you can create a wireframe version of this for viewing. What's interesting as well is that you can use the clipping tab. So with the clipping tab, you're able to clip in the X, Y, and Z direction. So then you can scroll through to look at how that voxel changes across your drill hole traces. Perhaps more interestingly, though, is that you can do a data clip. And so with a data clip, I'm actually peeling away my lowest values of molybdenum, isolating myself with the highest values. And you can type in those values here as well. So if your data is in ppms, then these values are in ppms as well, and then you can modify the numbers that you see here. So another interesting thing is once you've done a data clip here, and you can see which where you might have some interesting resources, you can look at the Attributes tab and the Visible Cell Statistics. So it will tell you some basic statistics for what you have visible here, including a volume, but keeping in mind that the cell size you chose and the interpretation distance does affect the volume calculation. But you also get max, mins, and standard deviations as well. So based on this information, what you might want to do is create a surface for it. So we call this an ISO surface at Geosoft, and here's an example of an ISO surface at 0.075 for the value of molybdenum, and here's one as well. So you can create multiple ISO surfaces that represent a single value along the surface. It's a smooth data shell, essentially. You can change the color of them, you can change their transparency, or change them to a wireframe view, as you see here. In the clipping tab, you are able to clip them as well in the X, Y, and Z axes. Another interesting thing is that you can export these ISO surfaces to an AutoCAD DXF file. And that means that you can then bring them into your section maps. So you'll be able to see these where these ISO surfaces intersect your section map. In addition to creating a numeric voxel, so a voxel based on assay results, for example, or geophysics results along the drill hole traces, We can also create a lithology voxel. So a lithology voxel is based on codes or strings in your database. And what we've done is create a lithology voxel. Using the utilities, create lithology voxel, you're able to tell it what data to bring in. So if you want to bring in the rock types from the lithology table, reference the CSV file, which is our rock code file, which I showed you earlier, which gives a color and description to each of our rock codes. So once that is done, you can create the lithology voxel, and this is an example of it. And with the clipping tab, it's a little bit different from the other voxel I showed you. With the lithology voxel, you're able to turn off the units individually. You also get a volume calculation as well. But again, that's based on the cell size you chose, interpretation distance as well. But it gives you a nice idea of how that is, of your lithology units. Instead of creating an ISO surface, with a lithology voxel, or with lithology data, you can create a contact surface. And here it is. So this is a contact surface where it's basically connected all of the bottom of the last occurrence of a particular unit that I've identified. So in this case, I chose the unit that was called SS, and it has connected all of those occurrences through the drill hole traces to create this surface. So this is considered a subsurface topography. You can add this subsurface topography to your section map as well, and you get a profile in your section of where it intersects this contact surface. So the lithology data had a lot of missing intervals, and so you can see that there's quite a few holes in this surface data. So the more data that you have, the better for making a complete surface. We also have advanced tools which will allow you to force the fill of any holes that would occur in your surface. I mentioned earlier that the section grids that we created are automatically 3D georeferenced. So here's an example of the section grids that were created as part of the stacked section. So those are really easy to bring in under Add to 3D grids, plan or section grids. You can import them just through here. And I've also created a voxel slice, so you can create a voxel slice interactively on your plan map and then have that viewed slice in your 3D viewer. As well, I also showed you that you can draw section interpretations and have them georeferenced as well. So if you remember the section map I showed you earlier, I drew this interpretation using our CAD tools, and I was able to import that into our 3D viewer as well. Another interesting thing is the fence diagram. So here I have the fence diagram, which I showed you was exportable to a DXF format, and so this is what you would get as a result of that DXF export. You see that fence diagram in 3D. So hopefully you're able to see that easily enough. Taking a look at the Add to 3D menu, there's quite a lot you can do here. You can add a whole relief surface as well that isn't clipped to the drill hole extent. You can import voxels, create ISO surfaces. I talked about drill holes. Another thing you can do is import from a lot of different file formats. So for example, if you are using MapInfo, we can import tab files, we can import ArcGIS files, Datamine, GoCAD, Micromine, GemCom. These are importable formats, which you might find beneficial. Another interesting thing is that we can export whatever is in the 3D viewer to a 3D PDF. And so what that means is that you'll be able to send a 3D PDF to someone that might not necessarily have Geosoft or our 3D viewer. And what they will see when they open it up is your 3D model that they can rotate. They can zoom in and out of as well. And they'll also be able to turn layers on and off. So for example, you can turn off these layers. Anybody that has Adobe Acrobat Reader version 7 or above, which is a few years old now, has the ability to open 3D PDFs. So if you haven't seen this before, you're likely able to open them right now. The advantage of this is that you're able to send your 3D model to someone that doesn't have a 3D viewer. Also, these are just a collection of images, so there's no data attached to it either. If data security is an issue for you, then this is a great alternative. If you're also sending data to someone that doesn't have our Geosoft license, they can download our 3D viewer from our website for free. And that's another option as well. So that's the 3D PDF. And one more thing that I did want to show you is for every map, grid, or database that you import, metadata is automatically created. So if I was to right-click on any of these items in the Project Explorer, I can click on the metadata and you'll see attributes that were used to create this map, who created it, what map projection it was in, what data was used to create it, and this is done for you automatically, which is a really great thing. I believe that's everything within the target demo here, so I'm going to jump back into the PowerPoint and finish things off there. So one thing I did want to mention is our Seeker option or application. In all of our Geosoft applications and plugins, Seeker is our new utility for accessing geospatial data. And if you are already familiar with DAP, that was our previous version of it. So Seeker has replaced DAP and is available in Oasis Montage, Target Standalone, as well as Target for ArcGIS. And you'll see it in the menu under Seek Data. What this will allow you to do is type in a search keyword or search for an area of interest on the globe, and from that you'll get a list of results of data that's available for you to access. So it will include the Geosoft DAP server. If you have a DAP server yourself, it will include data from your own company. But we also have a web crawler that is continuously looking for geospatial data on the internet all the time. So if you click on the web option, you will see what is available for download from the web. We also can access web map services from the government and ArcIMS servers as well. So once you have entered your keyword and gotten some results, you can download that data for free by going to the cart option. And that data is automatically added to your open project in Oasis Montage or Target Standalone or Target for ArcGIS. So just to go over some of the key highlights here, we can create many different types of maps in Target. So this includes plan maps, sections, stacked sections as well, fence diagrams, strip logs, and 3D maps. We can display all kinds of data along the drill hole traces, so numeric bands, bar plots, posted values, posted text. You can create rasters in the background using the drill hole data. If you have structural data, you can create fracture density plots, stereo nets, tadpole plots, structural ticks in sections, and structural disks in 3D. Other quick highlights is that it is an easy-to-follow workflow that will bring you from initial import to your final presentation. So the drop-down menus that I showed you for surface mapping, DH data, and DH plot help you with that workflow. You can start at the top and work your way down, and so we've designed that so that it would be very easy for you to use. We have significant 3D capabilities as well. You can create voxels either using numeric data like your geochemistry assays or using code information. So for example, a lithology voxel using lithology codes. You can create ISO surfaces from the numeric data and contact surfaces from the lithology voxel. You can see, you've seen that the section interpretations are in 3D. They're georeferenced as well as any section grids that you create as well. And the 3D PDF option is a great option to use if you want to share your data with someone that might not have our software, or if you're protective of your data, it's a collection of images that the user can then open up in Adobe Acrobat Reader, rotate, and turn layers on and off. As well, you've seen how you can access more data with Seeker. So this comes with all of our applications, and we would encourage you to try it out to see what kind of data might match with your area of interest. So thank you very much for your time. Dima, I'll head it over to you now.
Thank you, Birgit, for such a great presentation, both the live demo and the overview. That was great. So we actually have some time to take some questions. We've received a few during the presentation. So one of our attendants actually was asking if you could please explain what a subset data is, Birgit?
Oh, sure. I think the best way is to actually come back in here. So this would be subset project. I am assuming that's what they meant. Basically, when you create a selection of drill hole data, you can create a subset drill hole project for it. So what does that mean? Well, I'll show you the selection tool. With the selection tool, we also have other selection methods as well, but this is the most visual. What you can do is select a group of holes to work with. And let's say these are the only holes that you want to use. So if you have a huge drill hole campaign, but you only want to focus in on a certain area, you can either just create a selection of them and then use that selection in creating your maps, or you can create a whole new subset project that only has those holes in it and nothing else. So it's a great idea if you have a very large data set and you just want to narrow it down to a particular set of holes. Does that answer the question?
Well, yeah, that's a great way to explain it. We'll go into another question, and then we'll also just keep an eye on that.
Okay.
With the fence diagrams, are they compatible with GMSys? Do you know?
I'm not entirely sure about that.
Okay.
I would have to look into that.
Well, we can definitely find out and get back to you, to the attendant, with regards to that question.
Yep.
There was another question with regards to importing data through the seeker. Is it readily available to import into the DH template, or do you need to define the channels?
Oh, actually it works really well if, for example, if you have a plan map, a lot of the data that's in Seeker is at the surface. You can have section grids in there as well, but primarily most of it is at the surface. And so when you import data from Seeker, it gets automatically placed into your plan map if you choose to. There's an option there to plot it immediately or to just save it to your computer, and then you can do what you wish with it. But yeah, it will be brought into your map automatically for you. Perfect.
And with the voxel model, is there any way to limit the voxel so it doesn't extend it above the Earth's surface?
Okay, that's a really great question. So with the voxel, it's down here, my 3D viewer. I'll just open up this one. So what this person has noticed is that it has, it intersects the topography here. So what we can do is actually clip the voxel to a topography under the utilities. So under utilities, voxel topography clip, it will clip any voxels that appear above the surface. And why would a voxel appear above the surface anyway? Well, because it's looking purely at your drill hole data irrespective of your surface. So it will interpret to a distance that might go over your topography surface, which is why we have that option to clip it based on the topography afterward. But what you'll notice is that even when you do clip it, it does keep the voxels that intersect the topography, so those are kept there.
Okay. And in the 3D viewer, are you able to digitize it all, Birgit?
Currently, there are no digitizing capabilities within the 3D viewer.
Okay. And with regards to displaying a cross-section, is there any way that you can define the cross-section in terms of letters, such as an XX or YY, instead of defining them by the coordinates?
Define them by an XX. Basically, when you define your section, it is either based on an interactive definition on your plan map, or you would type in the specific coordinates, and that's currently the way it's done.
Okay.
Yeah.
Okay. And someone actually was just wondering if you could possibly just talk a little bit about a fence diagram.
Sure. Yeah. So the fence diagram, under DHplot fence diagram allows you to specify which drill hole traces you want to include. So if I use the selection tool here, basically I can define a fence by clicking on the drill holes that I want to include in the fence. And so if I go from here to here to here to here, I'll create a fence diagram with these particular holes. And it doesn't matter what configuration you choose. It can crisscross. It can be quite messy, but that's how you would define your fence. And so once that is defined, you can then specify, that it should plot geology polygons, so it will create these polygons that connect the lithology from one trace to the next. And so the output that you get looks like this. And what you're seeing is from this hole to this hole, this is the plan view of it. So it's this segment here that corresponds to this segment here. And then the following segment on the right corresponds to the segment here on the plan map. And you're visualizing that. It's basically you can think of it as kind of a cartoonish view of connecting the dots, connecting the lithology units from one drill hole trace to the next.
Okay. Okay, and what about a stacked grid? Could you explain that a little bit more for us, please?
Okay, so I showed the ability to create a stacked section. So this is an example of a stacked section. And when you create a stacked section, basically it's just like creating a multiple section. So you would define that on your plan map. But then in the data tab, you're able to plot various different data along the drill hole traces. So one of the things that I chose was to plot copper, and to create a raster based on copper using minimum curvature. And so what you're seeing in the background here across all of these sections is the copper raster. And so that's an example of the gridding capabilities in section that you can do. These are all georeferenced in 3D, so you can immediately put them into your 3D viewer.
Okay. And are you able to define and view planes, such as faults, within the workspace?
There's different ways. Like in the 3D viewer, you can here it is. You can add a plane that's at a specific orientation, so that could be used to define a fault plane in 3D. In a section map, you could try creating a contact surface that represents the fault plane, or you would use the CAD tools to draw it in yourself.
Okay, great. And the attendant that was actually wondering about the fence diagram was actually hoping if you could explain the fence map a little bit.
The fence map?
Yeah, just the different components of it.
Okay, so the fence diagram, what you're seeing here is you're looking basically north. So, and then in the plan map that you see on the right, in the legend here, so that's a top-down surface view. So you're looking at basically at a cross-section that looks towards the north in that plan view. And then that data is being plotted here, connecting the the geology across the drill hole traces. Does that answer your question? So basically this portion of the fence map is viewing it in section, and this portion of the fence diagram is viewing it as a top-down surface map.
Perfect. Thank you for that explanation.
Okay.
Can you describe just what a relief surface is?
Yeah, a relief surface is essentially a topography, whether it's a subsurface or a surface topography.
Okay, great. And in one of the examples of the client section, it included significant intercepts. Was that a function of the section drawing tool in Target?
Well, there's different ways to create significant intersections. What you can do is plot them within the section tool. There's options to identify max-min intervals. But what you can also do is use our compositing tool. With the composite database, what you're able to do is specify an interval selection, and we have something here called significant intersections. And what you're able to do based on this is say that you want to have molybdenum values with at least this grade for at least a distance of how many meters you want. And so the output from this is you'll get the composite grades that will be at least this value over at least the distance that you specified here. And you can put in a cutoff grade, you can clip high values, and also include internal dilution intervals as well. So this is something that you can do in the database itself and then plot using the resulting database that you get. I hope that that clarifies it.
That's great.
Yeah.
Yeah, we have covered most of the questions. Does anybody else... Actually, sorry about that. There's a couple more that have just come in. We do have a couple more minutes to go over them.
Okay.
One of the attendants was asking if you can make a surface geology map displaying structure symbols and measured values in text.
Okay, really good question. So I'm going to open up the first regional map that I had. And in this map, here's some geology polygons that I brought in from an ArcGIS layer file. Mm-hmm. And when it comes to surface mapping, yeah, you can import a lot of other different file types. You can use our CAD tools to digitize, but also under map tools and these symbols. Yeah, here we go. Under the symbols option, you can choose strike dip symbols, and then you can specify in the active database that you have. So whatever is the active database in your Project Explorer, you'll see the dip channels that you have access to. So you'll need a dip channel, and you'll need a strike channel, and so at Geosoft we call a column in a database a channel. And so if you have a strike channel and a dip channel, then you can modify the size. There's a symbol color, thickness, text orientation, and those can be then plotted on your map. I don't have data that would work for it right now, but okay. This is how you would.
And if you were working on a proposed drill for development, can you include that in information in Target? If you were trying to make another proposed drill?
Okay, yeah, there's lots of ways to incorporate proposed holes. For example, in your source data, you could have that as a drill hole data type, proposed hole. And then in the selection tool, you can specify to have that particular hole be plotted a different way from the other holes. Also, if you go into DH data, you can add a new drill hole from here using our dialog box. So in this case, you type in where it is located. In the next release that's coming out in June, there is a new tool that we're introducing which will allow you to create a new planned hole interactively from a plan map or a section map. And so there's more being done with that as well. But yeah, currently there are ways to handle proposed holes in a database.
Okay. And just going back to the faults, is it possible for us in Target to actually incorporate in more complex faults as opposed to them being like a plain surface?
In that case, what I would do is actually digitize using our CAD tools, okay. Or if you're using another program like AutoCAD or some other kind of digitizing program, you'd be able to import those into your map. So we can import a lot of different file formats. So more complex faults, yeah, you would, or more complex structure, you would use our CAD tools to do that.
Okay. You mentioned Esri being a partner and a lot of compatibility with the MXDs. Are a lot of these features that you covered today in Target for ArcGIS as well?
In Target for ArcGIS, there is a plugin that you can, if you have Target for ArcGIS, then you should be able to just automatically, you would create your maps as they are and import them into Oasis Montage or Target. And if one of your users does have Oasis Montage or Target standalone, they can convert their Geosoft maps to an MXD. So there are there's there's different companies that we have. Some clients of ours have both in their office. They will have Target for ArcGIS on some machines, and some of them will have Target standalone or Oasis Montage. And so the nice thing is that there is great compatibility across those platforms.
Okay. And just one last question. One of the attendants is wondering if they can plot data such as lithogeochemical data at, for example, 20 centimeter intervals as spheres or of different colors along the drill holes in 2D or 3D.
At regular intervals. So what I would probably suggest is, there's lots of different ways that we could do that. In the database itself, you could create a new composite database at fixed intervals for whatever data that you wanted to visualize. So that's one way, is to go to the data source. Also in the tabs themselves, like for a section map, in the data tab, this is how data is being plotted down the drill hole trace. So if I chose, for example, my molybdenum values, maybe numeric bands might be the best option for that type of data, and so then here you can put in very specific intervals to be plotted along the drill hole trace. If you wanted it to be at fixed intervals down the trace, then I would make a fixed interval composite database to do that first. That would be one way to do that.
Okay, perfect. Well, thank you for explaining that, and we really appreciate you taking all of our questions. If we have not answered your question yet, or if you'd like us to expand a little bit, please stick around. We're going to be online for the next little while. Otherwise, if you'd like to sign off, we just want to say on behalf of Geosoft, Birgit, and myself, thank you very much for your time and consideration through attending this webinar, and we hope that you found the webinar informative and helpful. If you're interested in attending other webinars, please visit our website at www.geosoft.com for updated information on upcoming webinars, and we also have public training events posted there as well. And if you have any further questions at all, please, at any time, please don't hesitate to contact us. So thank you, everyone, and thank you, Birgit.
You're welcome.